Worski with Infosync Technology Services. In the next 30 minutes, I'm going to show you why the utilities in control of their operations, their capital budgets, and winning awards today are doing one thing differently, how they made one decision differently, and how you can do that as a utility or a consultant or technology provider, whatever you're doing in the space. A quick background. Last year, had worked with a utility. I'm getting some notes. Let me do audio check and everything. Sounds like we're all good. So last year, we worked with a utility. Within the first 90 days, we found a $1 million plus water loss issue. They had a failure in their physical system. We'll get into that. But because we had built out the digital infrastructure in the system, we were able to find and fix that physical infrastructure failure. All done in less than 90 days. We're going to go through some quick stories about some different utilities. Let me test this out, make sure this is working right. I like pen and paper for these, so let me bring this in. Hey, perfect. All right. So we're going to go through some quick highlights. This is a utility I was just talking about. This was in Florida. Found a $1 million a year water loss issue in the first 90 days. Another utility, this was Southwest Florida, found illegal dumping in the sanitary sewer network. They had issues between 2 and 4 a.m. with somebody dumping who knows what into their wastewater system. Worked with the utility, found a 12% utility billing failure rate. Was able to find and fix that because of the digital infrastructure. Another utility who found a busted valve. This was over in Arkansas, leaking millions of gallons a year. They were able to find and fix this because they built up the digital infrastructure with DMAs and water loss. Another utility, this was in Tennessee, able to remove water quality complaints from remote area because they were able to monitor the different flows, levels throughout the system, and use the data to make good decisions with their physical infrastructure. Another utility was in the Carolinas. They improved their drinking water plant operations because they tracked their surface water quality with sensors, software, the digital infrastructure, so they could fix it on the physical side. Utility in Louisiana found where their staff was working 7 times harder than peer utilities. So I'll never forget the look of relief on their face when they finally got, it's like, oh, we're not less capable as a crew. We just have to work harder because our line breaks are 7 times national average. So that gave them the data clarity they needed to go out and fix it. Another utility was in Texas, optimized their sewer cleaning route so they always know the worst 5% to clean. Instead of just canvassing the whole system every year, they could focus on the worst 5% every single month and move forward. So if that is of interest to you and what you're excited about, how we as the utility industry can take digital infrastructure and really use that to improve operations, save our capital budgets, that's what we're here today about. Quick call out. I think we've got some attendees already on here. Let me see if I can see who's with us already. Let me take a look. All right, so we've got some people that have pre-registered. So we've got Tom Moore with Beppo, Joaquin with Xylem, Rob Christ with Jing Cloud, Manoj, Grav, Amir, Perry, Baker, Forrest, Michael, Caroline, myself, and we've got some others attending as well. We've got Grav, Yasser, Alec, Lee, John, Cynthia, Puneet, Raghu, Heather, Baker, Bridget, Jamie, Alan, Kalpana, Eric, Brett, Joey. And it looks like it's a healthy mix from water technology providers, water utilities, and consultants in the industry. So I'm excited about that. Let us continue to jump into this. So there's 2 promises that I want to share with everybody today on this live stream. The first is that you'll get a framework for how to implement digital infrastructure, smart water technology that actually makes sense, that you can move forward with as a team. The second item is how to implement that in 90 days. So how to go from daylight to design to deploy, all in 90 days or less, how to move forward quickly. So if you are with us in the live stream, we're on multiple platforms. So just drop a comment, whatever platform you're on. Let us know if that's what you're here for, to focus on connecting the digital to physical infrastructure, or if you were here for something else and wandered into the wrong live stream, still happy to have you here. All right, so a little bit about InfraSync. So we started InfraSync 2 years ago with really 3 main goals. Let me go back and sketch this out for everybody. There we go. So in the water industry, we've got 3 items that we're always working to bring into balance. So we've got water, we need it to be safe. And that means compliant with all drinking water regulations, wastewater regulations, everything else. We need it to be affordable. That EPA defines that as less than 4.5% of the median household income. I personally prefer 2%, but we can get into that. And then I also like to say abundant. That varies by region, as obviously Arizona and Florida, you'll have different needs. But when I think abundant, I think of 100 gallons of water per person per day, somewhere in there. So that's what we're all about as the water industry. At InfraSync, what we try to build, design, and support how we make drinking water, wastewater safe, affordable, abundant. A little bit about me and my personal background. Some of you may already know me, some of you don't. I grew up in Houston. I actually was flooded a few times growing up as a family. That's a different story for a different day, from hurricanes and natural disasters. But grew up in Texas, was good at math, went on several trips in middle school, high school to do service projects overseas, predominantly Central South America, with shallow water wells, hygiene infrastructure, wastewater infrastructure, everything else. And through that process, continued on through high school. I was good at math, so I was drafted into Texas A&M, essentially into the civil engineering school, specialized in water resources. Then I got out and immediately started to go to work as a traditional civil engineer. And what that looked like was going into a utility and fixing those issues with steel, concrete, building up better. But we're starting to run into an issue with that, which I'm going to get into. So the issue we're running into is the status quo is just tougher now than it used to be. So let me share a couple things with everybody. Let me get these in order. So the 5 forces that are really wreaking havoc on the whole industry. Let's go through those. I'm not going to dwell on them too long because I think a lot of them we kind of already know. The first, workforce. So whether it's the retiring workforce, depending on what source you're looking at, we're probably going to have somewhere between 30 and 50% of the workforce retired out by 2030, which is going to be tough for us as an industry to keep on working. The other item is that wages in the water sector are traditionally lower than other competing sectors, such as natural gas, electric power generation, somewhere between 30 and 50% lower. So it's harder than ever to attract people into the industry. We're losing people faster than ever, which is just making it hard. So that's the first of the 5 big forces we're working against, which is just the workforce. The second, which is water stress. So you can just see this map here of the US. We have plenty of water in the US. It's just not in the right spots. Where people live, which are predominantly cities, and the cities are growing, the suburban areas are growing, even a lot of the urban areas are growing. We're placing such water stress on their local environments. I know in Texas, we're estimating about a 4.7 million acre feet per year shortfall of water. And nationally, the USDA is projecting up to a 235% increase under the worst case scenario. And that's for agriculture, data centers, urban water. So our water stress is increasing as well. So we've got not enough water, at least in places we need it. Aging infrastructure. Sometimes I use the term obsolete. Sometimes I use aged. It's old. Circle of Blue puts out some good reports on this, but the majority of our pipelines, treatment plants are older than the people working in the water industry right now. We have not maintained an adequate repair maintenance cycle. Our water lines are old, our treatment plants are old, and they're at one of their first major waves of replacement, built in the 70s and 80s. They're all about 40, 50 years old, and they need some heavy replacement, which is expensive. Fourth, which is regulation. So whether you're looking at drinking water regulations for water losses, whether you're looking at PFAS regulation and the treatment plants, our lead and copper regulations and what that will cost. If you are in the industry, you know what a whipsaw it has been the last couple of years about the national regulations and what's required for PFAS, lead and copper, other items going on, the regulations. And then the fifth one, which is climate, weather, however you want to define it, the natural disasters are getting worse over time, or at least the impacts. So this is from 2024. I'm sure we'll see the numbers for 2025 somewhat soon. So I live right here in Texas, where we had quite a few of those in 2024. But across the whole country, you're seeing increasing disasters, hurricanes, thunderstorms, wildfires, other events. Okay. Yeah, Andrew, we've always had weather. What about that? Well, let's just look at what it costs. So these are the numbers from NOAA in terms of what FEMA has to spend and other agencies year over year. So if you look back here in the 80s, we're spending a little bit. And if you keep extrapolating that out, there's a very clear trend trajectory. The costs are going up. There's no way to get around this issue that we are being impacted more and more by weather events in our cities and in our communities. Great. So what all is this causing? Let's go back to our safe, affordable, abundant map, our diagram. Safe, affordable, abundant. We want all three, but we're being hit with these challenges. So whether that's the weather, the workforce, the regulations, the supply, and then the age of the infrastructure. Not necessarily people, that's a different issue, but the age. Let me see if I can zoom out just a little bit here. There we go. All of these are causing the status quo to really start to fracture and fall apart. We're seeing utilities, whether you're looking at LADWP with the Palisade fires, whether you're looking at Clyde, Texas, with the bond ratings being downgraded. We're having these issues in the utility sector. And so we're looking at which of these ways do you go as a utility with the status quo method, with traditional physical infrastructure, and what can you actually do sustainably? Of course, we want safe, affordable, abundant water. The trick is, how do we get all three? And what's traditionally worked before, I think, is starting to fall apart. And if you think, well, Andrew, is this a new problem? Haven't we always had these issues? Like, well, yeah, but let me show you one graphic that's hidden deep inside a report in the US Treasury. So this is showing what the federal investment is in the water sector. So if you're looking at over time in the 70s through the 80s, we had pretty high federal participation, upwards of 20%, and that's just been trending down very clearly over time. We got a little bit of a bump with the Bipartisan Infrastructure Act, but you can very clearly see that it's trending down over time. So if it feels harder than it ever has before, there's a reason for that. Those five forces are impacting us as an industry greater than they ever have before, and we're getting less help than ever from the federal government in paying for all this, which is really impacting this affordable line item, and that utilities are increasingly on their own to best manage their budgets. Okay, so where do we go from here? Well, as I mentioned a little bit earlier in my background and my story, like any good Texas kid that was good at math, I became an engineer and started to solve problems with steel and concrete. So I got out of school, went to work locally in the Texas area, some projects around the country, but one of my first projects was a 60-inch water line for San Jacinto River Authority, then a 90-inch wastewater line for San Antonio Water System, then a huge canal. This was 500 million gallons a day for Coastal Water Authority. Worked on a 10 million gallon surface water, a 10 million gallon a day surface water treatment plant for City of Pearland, a 200 million gallon a day wastewater lift station for City of Houston. Lots of giant, big infrastructure projects. And they worked, and they continue to work well today, but they are expensive. And so finally, I think I found a better way through my time in the tech side of the industry and others that we're going to talk through today. So if you're thinking about what you do as a utility, let me sketch this out for us. All right. What we do as a utility. So we start from the river or groundwater, wherever you're starting from. And then that moves into the treatment plant. Just going to draw a quick little tank here for the treatment plant. And that moves to the pipelines. Draw some little pipelines here. And that moves to the drinking water meters, the consumption in the households. Then that moves into the wastewater manholes, to the treatment system. And then that moves into our wastewater treatment plants. That's a clarifier. And then finally back to the rivers. Excuse the handwriting, going fast. If we look at that, that is our physical infrastructure. So all the way from river back to the river, or water source back to water source, this is what we as an industry know and manage extremely well. So across this whole cycle, we know and we work with this. We take a gallon in, we move it across the entire chain. Well, what I found out, what I discovered is there's an entire other infrastructure. There's how we get data in with the collection, the transmission. There's how we do the database storage and how we move that around. There's how we do the analytics with charts, graphs. There's how we do the automated reporting so people can get live views on what's going on. Then there's how we do the integrated control systems with the automation logic and everything we do as utilities to control the systems. So the revelation I had is, whether we admit it or not, we have an entirely parallel digital infrastructure ecosystem. But instead of drops of water on the physical side in and out, we've got drops of data coming in. And then on the other side, we have action going out. So if we're looking at this entire ecosystem, the way out of the status quo, the way forward as an industry, is we've got to bridge the physical and the digital infrastructure together. These aren't two separate ecosystems. These are two interconnected ecosystems that need to be designed and looked at together. I like to sketch it out and talk while I'm going, but I've also got a cleaned up graphic view of here. So as you're moving everything through each gallon, through the whole process, this is the right strategy or approach or framework on how we're going to overcome this as an industry. We've got so many different utilities solving their problems in new ways because they've built out this digital infrastructure system. This is not a risky concept. This is how you bring order and control to what you're doing as a utility. So let me go through some quick examples about how that strategy is actually working out. So here's a utility. This was in Louisiana. I got engaged with them and built out their digital infrastructure to really do some analysis of their system. This was one, and you can see the picture of me and Daniel there. Being able to go in, look at their data, show operations. You've got seven times the line breaks and 13 times the water quality complaints as average. You have big physical infrastructure issues, but now you know where. Now you can go in with a pipeline replacement plan to go fix all those issues. So just giving them the data was huge and empowering for them. The second one I'll talk about, this was a utility in Florida, really Southeast Florida. They had a very large water loss issue in their distribution system, but they didn't know whether this was apparent losses or under registration, under billing through the meters, or whether this was actual real losses out in the water distribution system. Spoiler alert, it's a combination of both, but they didn't have the right data to inform their physical infrastructure until they had built out the digital infrastructure. So within 90 days, came in, assessed their entire physical digital infrastructure, gave them a plan to get back on track in terms of what they're doing with their metering system and their physical pipeline systems as well, to bring their water losses under control. As a utility, actually in Immokalee, we presented with them at the Florida Drinking Water Wastewater Conference late last year in Orlando. They saw the need for this. This was the utility that caught some illegal dumping between 2 and 4 a.m. And so they've built out almost an end-to-end digital water and wastewater digital infrastructure with distributed sensors, so level sensors, pressure sensors, flow meters across their entire water and wastewater collection distribution systems, their treatment plants, both on the drinking and wastewater side. Now they've got 24/7 real-time visibility into all their water loss issues, their sewer line breaks, overflows, and that's what they're implementing right now. Another utility use was in Texas, where they knew they had inflow and infiltration issues, and it was really where do they start? And it wasn't just limited to one part of the system, but by connecting their digital infrastructure together, we were able to see where the lift stations are perhaps pumping too hard, or some pumps are running higher than they should be. What areas are having excessive inflow and infiltration compared to the drinking water flows? And the result of this is they had a much healthier understanding of their physical infrastructure system and their flows. And unfortunately, it wasn't just one giant issue to solve in terms of, oh, we found one big problem. It was distributed across their entire collection system. They've got so many different smaller issues to go fix and resolve, such as sewer line breaks from storm sewer issues or illegal connections or other items, but at least now they know where to go look and how to fix all this. So those are just different examples of utilities implementing this digital infrastructure approach and the results they're seeing from that. I get particularly excited about how we can do this quickly. And so if you have looked at digital infrastructure before or implemented it, you may be thinking, well, Andrew, yeah, we've tried this before. We've done bits and bobs of digital technology before. How do we pull all this together to move forward? Well, what I've experienced is if you can get a sensor or software or something, but you don't necessarily have the correct digital infrastructure set up, there's no spot for that data to go. Can you imagine on the drinking water side or the wastewater side at a treatment plant? Hey, we're going to go get a new pump or a new chemical doser or a new aeration blower or something, but you don't have the basin or the infrastructure set up to take that component, to take that equipment. You're not going to just buy a pump and go randomly connect it up to somewhere in the plant. You're going to design it. You're going to think about it. Here's the infrastructure we have in place. Here's the right technology component that goes into that to get the results we need. So if you have the right framework, the right digital infrastructure, you can take almost any sensor software technology, implement that, and be successful. The critical item is how you go about that. And I think speed is really important. So the question isn't really just how or if the technology works. It does. It's what's your digital infrastructure ecosystem look like. So it's got a system it can plug into and work. So I personally like a 90-day plan. Let me go back to the paper. 90-day plan, I like to break it into 30 days for each of these. So the first 30 days is the daylight, and that's where you just uncover the issues and what to do. Then spend 30 days on the design side, planning out exactly what you're going to do with the hardware, software, the digital infrastructure. And then 30 days on the deployment, like move fast, get some results. 30 days is important because that's short enough time to make sure people don't get distracted or it becomes less of a priority, but it's long enough that you can get consensus and get the whole team on board. So this is something that's important. Don't just buy and try going with a clear plan. So let's go through these one at a time, how this process actually looks like. So there's 3 steps I like to go through. So daylight, look at your entire physical infrastructure system, your entire digital infrastructure system. The key component of the daylight phase is a full inventory of your physical system, a full inventory of your digital system. And by doing that, you can start to spot what areas you want to improve on it as a team, where deficiencies may be, opportunities may be. If you're listening to this webinar, part of the giveaways we typically include is the smart utility framework and design packages. And so in there, we've got some of the top AWWA and other industry criteria, the top 5 to 7 for drinking water and wastewater. And that could be pipeline breaks per mile, water quality complaints per thousand accounts. It could be total non-revenue water. Likewise, on the sanitary side, it could be overflows per 100 miles of sewer, your inflow and infiltration rate as a percentage, and other issues related to the wastewater system. But that daylight phase, that first 90 or first 30 days of the 90-day program, it's an assessment of what you have and where it's really going to move the needle to do something big and meaningful. And so you go through that. We can do it pretty quickly based on the data and the dashboards we have set up. Absolutely something you can do yourself in GIS or Excel or other tools. But the important thing is, what's my physical system, what's my digital system, and what's the big area for improvement? Okay, so after the first 90 days, great work. You've identified the problem, and a problem well defined is half solved. Now you're going to move on to, one of my favorite parts, the design part, at least most of the engineers' favorite parts. So this is the design phase. So this is when you're looking at your entire system. This is an example for district metering areas. You can do this for sewer sheds, treatment plants, whatever you uncover during that phase 1 to really focus on. And so that's sketching out at scale, what would we want our system to look like? And coming up with something called the minimum effective dose. Like, that's a medical term used for drugs, pharmaceuticals, but I'm starting to use it for technology. What's the minimum effective dose you need to have for this technology? Is it 1 sensor? Is it 10 sensors? What's the right level of software, professional services to bring all this together? So let's go back to this example. If you're trying to do a DMA or a water loss network design, sketch out how many DMAs could you actually use? What would it take to do 1 full DMA, and start monitoring the results from that, and start to sketch out on that framework, what's the hardware required, the software required to get that data stream all the way from collection to action. So in that design phase, the intent is not to fully design the whole system and everything. It's to place parameters around this first 90-day approach and how we're going to define success for that. Usually a clear deliverable for your team, the board, or whoever's going to be approving the budget for this is extremely helpful. Want to be able to equip or empower you or whoever in the team is doing this to show up, not saying, hey, if we do this, it's going to cost us hundreds of thousands or millions of dollars to move forward. It's like, that's not quite the message. It's, hey, we know we've got these problems. We've come up with a design or solution to fix these problems. With this investment, now we can save hundreds of thousands or millions of dollars. And this is the step 1 in doing that. You want to be able to show up with a design with a really positive ROI. Got lots of examples about how to do that across finances, operations, capital improvements, regulations, and implement all that together. All right, so you're through the design phase. You're at the right in the middle of that 90-day sprint. All right, let's move on to the next 90 days. And so this is the deploy phase. And I'm showing more generic software, hardware examples because I don't want to give preference to any specific vendors or anything. These are tools built in Power BI or quick dashboards that are applicable to a lot of utilities. Let me see if I can zoom in here to make this a bit more clear. There we go. So this is the deployment phase. So actually go deploy. This is building around that drinking water loss example. Get the sensors out in the field, at least minimum critical mass. Then go deploy your data systems and dashboards to start tracking issues. So for example, you're going to see right there, there's a drinking water loss issue that showed up on that day. And you can go find the zone in the city where that's been identified by having these together. You need to be able to, with the deployment, get the equipment out in the field, get the digital infrastructure set up correctly, and then get results quick to make sure that you're getting the team buy-in. And as a utility, you're seeing the results for this quickly. You can always scale up to future phases in terms of going from the phase 1 or the pilot to the full implementation. That's always a future consideration. But what's really critical in that first 90 days is get something in the ground functional that your team has a high degree of confidence will have some success. even if not a fully paid for itself ROI, at least enough data to show how you'll achieve that over the next year or so. All right, so we've walked through that 90-day plan on how do you go from daylight to design to deploy. Um, Wanted to see if we've got multiple platforms open. Let me check to see if we've got any questions or comments so far. I'm going to go through some Q&A that I'm getting from some different platforms. And if you've got something, feel free to drop in a comment, whether you're on X or LinkedIn or the webinar platform. So some sample questions that I'm seeing come in. Um, all right, I'm getting one. What are the biggest risks of the staying with the status quo? Um, how do I Yeah, what are the biggest risks? It seems to be working. I'm paraphrasing this. Yeah, so the biggest risk for the status quo are it's getting harder every year. And so this isn't the analogy of that frog being slowly boiled alive until something breaks. So we saw this with utilities such as Flint and Clyde, Texas, and then the other one, Jackson, Mississippi. And there are other utilities where they were functional for a long time and the status quo worked until all of a sudden it didn't. And then as soon as they hit and drove off the cliff in terms of the water safe, affordable, abundant, one of those three items, it really caught up with them quickly and really just devastated their communities. If you've been putting off deferred maintenance for so long, then it's going to be just a huge shock to catch up on affordability all of a sudden, which is where this digital ecosystem comes into play in order to manage the operational and capital budgets. Um, Getting another one. How much does this cost? What are the budget limitations? So let me. How are we doing our time? I'll make a quick example of this. Probably won't sketch it out. The largest budgets at utilities are typically the capital improvements budgets, sometimes the operational improvements. And so you don't have the budget to not afford the digital infrastructure, is what I'm trying to get at. The physical infrastructure capital improvement program, or the CIP, usually in the millions, tens of millions, are larger. Your digital infrastructure is supporting that. And so if you are spending 10, 20, $30 million a year as a utility and you don't have the digital backend, there's a huge risk that you're spending that money on the wrong projects. So for water loss, if you're doing neighborhood by neighborhood pipeline replacements, you can go with random, age, material, or the data driven or the digitally driven approach. You'll see multiple improvements on the ROI for the digital investment if you can figure out a way using the data, which is pretty doable once you have the data in place, to look at all the neighborhoods across your city, all the zones, and figure out where the highest water loss issues are coming in a specific neighborhood and focus all of your water loss efforts there, you get a far better return on investment on your capital projects. And the smart utility program should more than pay for itself, should have a very high positive ROI. We're usually looking for at least a 5, if not a 10x return on investment when it comes to capital programs. And so if you're talking about budgets and where you get this, I always say look at the capital project budgets. Usually there's quite a bit in there for like the planning, the preliminary design phase that can be used to support the digital infrastructure and the planning to get all this in place. All right, another question. The cybersecurity, we could go through that more in detail, but I'll say the water community, we've got lots of great vendors, software, hardware, technology vendors. There's NIST, there's SOC 2 compliance. I'm more than happy to talk with any of the IT or OT directors in terms of making sure they're comfortable moving forward. A lot of the questions I usually get are just people don't know, which is fine. And so we can just talk to the IT department and introduce them to the standards we have as the industry. Okay. I think we are 5 minutes over time and what I really wanted to do. So let's go ahead and wrap this up. We walked through the major things at the beginning. I said you'll get the framework or the approach for the physical, the digital infrastructure, got a 90-day plan. That's the daylight, design, deploy approach. If you want to move forward with this, you can certainly do the do-it-yourself path. in terms of using our tools, resources, planning this out yourself. There's also the done with you approach, which is where we come on board, help you out as a utility design and implement this in the first 90 days. There's also the done for you, which is if you are really need some additional resources, we do have teams that can come in and almost do a lot of the turnkey technology deployment. Not operations of the utility, we don't do that, but in terms of the sensors, software, the digital infrastructure, design and deployment. For those of you on the call, thank you so much for spending part of your day with me talking about digital and physical water infrastructure. I get pretty fired up, passionate about this. I love what I do and love doing what we can to make our water utility safe, affordable, and abundant. Thank you so much for being part of this. If you're on this, you'll get a follow-up email with next steps or what it looks like, the free resources mentioned in the marketing emails and the sign-up page. I appreciate everybody being here. At the moment, I don't see any other questions to address, so I'm going to go ahead and wrap it up here. And thank you all for joining. Everyone, take care. Have a great one.